What's up, math scholars? What's up, math scholars? We're doing Matrices Day 2, and we're making a video because the flu is going around and there are some kids out sick throughout the day. Okay, so who's excited? It's our last day on Matrices, and tomorrow we're just doing a fun little group Polaris quiz. You can pick your own groups, and hopefully everybody will get a perfect score. Who's excited? Yay! Woo! Let's start the day with matrix multiplication and talking about whether these are compatible for matrix multiplication or not.
No, they aren't.
Well, we don't know that yet because we don't know what compatibility even looks like with matrix multiplication. But we know they're not compatible for adding or subtracting, right? Because for adding and subtracting, we have to have the same exact dimension. That's not the case for multiplication. You don't have to have the same exact dimension. What's the dimension of this one? 3 by 3. What's the dimension of this one? So to be compatible for matrix multiplication, the middle guys in here have to match. So these are not compatible. But if this had been a 3 by 1 or a 3 by 3 or a 3 by 4 or a 3 by 5, then they would have been compatible. Okay? But they don't have to be exact carbon matches to be compatible. You ready for next slide?
Yeah.
Okay. Are these compatible for matrix multiplication? How big is this first matrix? 3 by 2. How big is the second matrix? 2 by 2. The middles line up. So guess what? These are compatible for matrix multiplication. So you basically have to make sure these middle two guys match. And this 3 here and this 2 here are also important. That's going to be the size of the answer matrix. So I know my answer matrix is going to be a 3 by 2. So I'm going to go ahead and make myself a 3 by 2. You can do that too. It's not exactly the right size of 3 by 2. The 3 by 2 will have 3 rows and 2 columns. Okay. All right, so matrix multiplication I find super fun. I think it's like solving a little baby puzzle. It's not what you would expect it to be at all. What you're going to do is you're going to circle row 1 in your first matrix, and you're going to circle column 1 in your second matrix. So you're already thinking this is shaping up to be a little strange. Matrix multiplication is a super cool combination of finding products and sums. What you're going to do is you're going to find the product of 1 with negative 4. I'll jot this down so you can see it. Then you're going to find the product of 6 and 1. And then you're going to add those two products. So it'll be, most of the time I do it in my head. I'm writing it out because you're new. It's going to be a negative 4 plus a 6. What's a negative 4 plus 6? 2. And since we match the first row with the first column, the answer goes in row 1, column 1. That's how you do it. Isn't that weird? I love it. It's pretty fun. It's strange, but fun. Let's try another matchup. Let's do row 1. I'll use green this time. With column 2. That'll give us the answer in row 1, column 2. So we're going to do the product of 1 and 0 and the product of 6 and 8. And you'll add the result of those two products. What would that be? 48. Good job. So ask questions at any time because I know this is very weird. So we're going to do 4 more matchups just like that. You're always matching a row with a column. Let's match row 2 with column 1. So you're going to match 2 with the negative 4 and 5 with the 1. 2 with the negative 4, 5 with the 1. Find the products, add them up. What would that be? Good job. They're getting it. Yeah, so 2 times negative 4, 5 times 1. Bam, bam. I normally use my fingers and I point. Bam, bam. My next matchup should be row 2 with column 2. Bam, bam. 2 with 0, 5 with 8. 2 with 0, 5 with 8. What would that be? 40. Yep. All right. I have 2 more matchups. The 9 and the 7 with the negative 4 and the 1. 9 with negative 4 and 7 with 1. Negative 36 and 7. Negative 29. And finally, 9 and 7 with 0 and 8. So 9 goes with 0, 7 goes with 8. 6. Are these two compatible for multiplication? What do you think? Good. So we got a 2 by 2 with a 2 by 2. They're compatible because these two I just underlined match. How big is the answer matrix going to be? 2 by 2. This is the most famous type of problems, the 2 by 2s. They're easy and fast to do. I'll let you write it down and then we'll try it matching our rows with our columns. Alright, so we have our first row with our first column. 1 times -4, 2 times 1, add them up. What would it be? -2. Good. I like to use a different color each matchup. Let's use green. Row 1, column 2. 1 multiplies with 0, 2 multiplies with 8, and then you add them up. What'd you get? Me too. Now we're going to do row 2 with column 1, 4 with -4, and 6 with 1. Add them up. So -16 and 6 is -10. And finally, last color, 4 and 6, 0 and 8. 0 and 48. Good. Now, if you're like really hating this and you're like, oh, matrix multiplication is terrible. Who invented this crap? I've got good news. I'm going to show you how you can input these matrices in the calculator, and the calculator can do the multiplication for you. I want to show you how it's done by hand, though, in case you're into this stuff, because in college you could take linear algebra. It's a course with nothing but matrices. It was one of my favorite courses, I promise you. It sounds super fun, doesn't it? All right, it is calculator time. There's a whole world yet to be discovered called matrix world. I know we've been in stat world this year. We've been in graphing world this year. We're about to enter matrix world. Who's excited?
Me, I'm excited.
Second, matrix. Right here.
Wow.
Here's the world. Most likely you don't have any matrices put in. I have 3 put in right now. But you're going to go over to edit. And what our game plan is going to be is to input this as matrix A, input this as matrix B, and then to have the calculator simply do matrix A times matrix B for us. Okay? So you'll go to edit, you'll hit number 1, and that allows you to input matrix A. You have to tell it the dimension, so I'm going to tell it that it's a 2 by 2, and then you just enter all the numbers. Now there's no button to hit save. Once you're done inputting it, you'll just quit Matrix World and it will be saved in there for you. So I've got my matrix A in there. My next job is going to be put matrix B in there. So I'm going to quit, go back in, second matrix, go over to edit B, and also input a 2 by 2 for matrix B. 5, 6, 7, 8. So it takes a little bit of time. I was telling my other class, the calculator can do a lot of things with matrices, but half the time it's almost quicker just to do the calculations by hand.
Are we going to be allowed to do this for the quiz?
Yeah. All right, we're all inputted and ready. So I'm going to go back out to the home screen. The actual multiplication will happen on the home screen. You'll do second matrix 1, that'll grab matrix A for you, times second matrix B. Bam. It multiplied it for me.
Oh my gosh.
19, 22, 43, 50. Hello, people in the video. I want to ask my class what they think if I would reverse the order of these and do matrix B times matrix A. Do you think we'll get the same answer?
Yeah.
Let's try it. I mean, most of the time in math, multiplication can be reversed.
Okay, it's not going to be the same. You can get it. No. It's not going to be the same just because how we're talking.
She's been in one too many classrooms in her life. It's different!
Why?
And here's why. It's going to be a totally different row matching with a totally different column. So when I'm going in this direction, it's 1 and 2 matching with 5 and 6. But if I'd be reversing it, it'd be 5 and 6 matching with 1 and 3. So the numbers are totally different matched. So basically what you need to kind of remember is matrix multiplication cannot be reversed. It's not commutative. Yeah, in fact, let's talk about compatibility. Let's say matrix A was a 3 by 1 and matrix B was a 1 by 7. Are those compatible to go in this order? Well, what if I reversed it? I took a 1 by 7 and said multiply that by 3 by 1. Suddenly, they're not even compatible when I reverse them. It's crazy. Okay? All right, before we run out of time, I want to get to the concept of determinate. It does show up on the ACT very often. Every time I've seen it on the ACT, they provided the formula, which is awesome. They flat out have said to find the determinant of a matrix, take the value of AD and subtract off the value of CB. So that just means find this product, and subtract the results. Okay? So we'll try to find the determinant of this matrix down here. Hey, people at home, so all we did was 4 times 6 got 24, did 2 times 1 got 2, and then subtracted them 22. So determinant is one of those things, I think it's quicker to do by hand than take the time of inputting this into the calculator and having the calculator do the determinant. Now, what if you were asked to do a determinant of a 5 by 5 matrix? Then you probably would just want to input it in the calculator. You can find determinants of any square matrices, so 3 by 3, 4 by 4, 5 by 5, 2 by 2. Let's use our calculator to find the determinant of matrix C here. We haven't inputted a matrix C yet. Second, matrix edit C. I think I have it in from an earlier class, so I've got it. I'll give you time to get into yours. So yeah, Emma already did it in her head. She's like -9 minus 20. It's -29. It's quicker, right? But I want to show you guys where the determinant button is. Just in case you would have to do a 3 by 3 or something. Second, matrix edit is where you put them in. Second, matrix math is where you can see all the math things that mathematicians do with matrices. Which one do you think is determinate? The first one. It's a pretty famous thing. So we're going to do the determinant of second matrix C. And Emma was right. It's -29. Okay. So you're learning all this fun stuff about matrix world. Yeah, I do it by hand. If they ask me to do it by hand. Yeah. Huh?
So maybe when you have a chance, you can help me like when you're done with the video.
Sure. All right. I want to show you the 2 ACT problems I found that have to do with matrices because they put variables in the matrices. And that's a surefire way to make sure kids aren't just using the calculators. It says the determinant of a matrix ABCD is equal to AD minus CB. What must be the value of X for this matrix to have a determinant of -16? So do you think like plug and chug would work? We could put the numbers in for X? Yeah, it might take a real long time. So I'm going to show you how to do it faster, like how a math teacher would do it. I would take this diagonal, find the product. I would take this diagonal, find the product, and I would subtract, because that's how a determinant works. We want the determinant to be a -16. Now, I turned to my class first period and I said, how would we solve it from here? We've done this hundreds of times this year.
Oh.
We're not dividing.
Square root.
We're not square rooting. We're going to bring the 16 over, get it all equal to 0, and finish with factoring. This is a skill you end up using so much on the ACT, it isn't even funny. So keep in mind, if it's a quadratic, if you have a squared and a linear and a number, get everything on one side and factor it. How would this factor? So the answer is 4. Our plug and chug friends eventually would have gotten 4, but it probably would have taken them longer than the 30 seconds it just took us. It's all about time and getting the answer quickly on the ACT. A -4 times a negative. Oh, so if we're going to put a 4 here and a 4 here and a 4 here, he's checking the answer. It would work because it'd be 16 minus 32.
Wait, the determinant's -16.
Yeah, exactly.
Correct. 16 minus 32.
Yeah.
It works. There's one more similar but different. Found this on the ACT. For what positive real value of k, if any, is the determinant of this matrix equal to k? And notice, they did give you that formula again, which is pretty nice of that. So we want our determinant to be equal to k. So I can do k times k, which is k squared. I can do 4 times 3, which is 12. Subtract them, equal it to k. I'm going to turn to the class and say what I said a couple minutes ago. How would we solve from here? Subtract the k, get everybody on one side. And hot dog, it is another factoring problem. I could take a practice ACT test today and probably end up doing factoring at least 15 times on the test. Is factoring such an important skill?
That's literally 1/4 of the problem.
I know, factoring, you can use factoring a lot and solve things. So what are we going to get? -4, +3? So the answer would be B. They don't -3 would also work, but they didn't give us that choice. All right, we're going to end the day with one last concept, inverses. The last one, I promise. Inverses. So if I would give you matrix A and I would say find the inverse, there's not an inverse button in that matrix math menu where we just were, but you can use the -1 as an exponent to find the inverse of something. So you're going to store in matrix A, you're going to go to the home screen, and you're going to do A to the -1 power. That's the game plan. Okay? So let's store matrix A for fun practice in storing. It's a 2 by 2. -3, 5, 7, 8. Second, matrix edit. That's where you store things in.
Yeah.
And then once it's stored in, you quit. And you're just going to do matrix A, so second, matrix 1, to the -1st power. And that'll find the inverse for you. Oftentimes, inverses are pretty yucky and full of decimals. So I'm not even going to write it down, but my inverse is full of yucky decimals because to get an inverse, they switch numbers around and divide everybody by the determinant. So they divide everybody by a negative, pretty large number. Whatever -24 minus 35 is.
Wait, so I did it, I put that in my calculator.
Yeah.
And then, so I put that in my